Hello, students. This is Professor Reena Randir. We'll go over the most important points of energy efficient buildings. So this picture is the ceiling of the green building at UMass. And there's lots of different concepts that were considered when they were building this building. And I hope you visit it one day. The learning objectives of our time together is to understand the significance and the benefits of energy efficient buildings. To describe the methods that's used to determine the efficiency of a building. Some of the design elements. We'll go over what embodied and operational carbon of buildings is. And we'll understand some of the terminology in energy efficient buildings like sustainable buildings or smart building, intelligent building, green building, and so forth. And some of the policies that's out there to make our buildings more energy efficient. So the objective as a community is to have a energy efficient city or energy efficient community. So the main goal as always, has been to reduce the carbon footprint as we transition to clean energy in the next 30 years. These are just some reminder slides. A very interesting facet is that the richer the country is, so here the picture in the bottom is showing the GDP per capita. So the richer the country is, more the energy consumption. So here the picture on the left shows if it's orange or red, it means the per capita energy consumption is very high. So there's this correlation between GDP and energy consumption, and another correlation with the energy that goes into buildings. So it shows that richer countries more energy, and they use more energy for their buildings, and also that's why the carbon footprint is also high in these countries. When we talk about energy consumption by sector, you can see, so the residential buildings and commercial buildings, almost close to 40% of all the energy goes into buildings. And here's some alarming statistics. The United States have less than 5% of the world population, but we consume 16% of the world energy. Whereas you compare it with Europe, they contribute to only 6% of the world population, and they use 6% of the energy. So again, energy efficiency and reducing energy consumption by the building sector is vital as we try to meet the energy goals. Here's another interesting fact. Human beings spend about 90% of their time in the buildings. So the building sector is accounting for 76% of the electricity consumption, and 40% of it is going to buildings. So 40% of the carbon emissions are coming from buildings. So that is why it is very important for us to understand the energy use by buildings. Here's a repeat of what I said, and this is showing how Americans use electricity. 15% goes for cooling, 12% for heating, 5% for lighting, another 16% for heating. So a majority of the greenhouse gas emissions come from buildings. This slide shows what embodied and operational carbon is in buildings. So this is like a life cycle of carbon emissions from the beginning to end of a building history. When you say embodied carbon, it is talking about the carbon footprint that is involved in the production of the building materials, the transport, the installation, the demolition, and recycling. So that is embodied carbon. But when we talk about operational carbon, it is talking about the carbon that is emitted when the building is operational, like utilities and so forth. There are many government agencies that monitor this. See here, California Act of 2017 required that contractors disclose the greenhouse gas emissions of their building materials. There's another act, the Better Building Act, reduces the energy use and pollutions from large buildings. So this is only a sample. There's like several of them. So in this picture, it's showing, so this is the timeline of greenhouse gas emissions. So when raw materials are extracted, so in this case, they're extracting wood from a forest maybe. So if it was a sustainable forest, if it was replanted, then the carbon footprint is low. But in general, if trees are just cut down for buildings, it throws a lot of carbon dioxide in the atmosphere. Transport costs the environment. And when it is processed and changed, it costs the environment. And then it's transported to the site where the building actually happens. And then after the building is built, there is both embodied and operational carbon footprint here. And end of the life of the building, the building is taken apart and it is maybe like taken to a landfill or recycled. Again, there is the carbon emissions continue. So a builder who's thinking about energy efficiency should think about reducing the energy use in every step of the carbon cycle of a building. So what is an energy efficient building? So an energy efficient building is defined as a building that is designed. So it begins even before the building is built. So design elements will be considered to reduce the energy use in a building. So the energy use in a building refers for the energy that is used for the building envelope, which is very important. Insulation is very important. HVAC, the heating, ventilation, and cooling of the building, the lighting of the building, and all the appliances that's used in a building. So energy efficient building is environmentally friendly, using just the bare minimum of energy that is needed for comfort, safety, and security of the people who are living there. So it is divided into 4 categories. One would be the envelope of the building. So this is talking about the walls, the roofs, the ceilings, windows, doors, etc. So for example, we have seen ceiling insulation in our homes, right? It is very important to keep the heat in, especially in cold countries like ours, states like us. Thermal barriers, air barriers. So all of these will play a huge role in energy efficiency. Efficient lighting. So this is like a summary picture. So this is like a typical home with a basement, first floor with kitchen and living room. And then the bedrooms are upstairs with bathrooms. Energy efficient windows. So we've heard of double pane windows, and also there's energy efficient paint that can reflect hot waves in the summer. Ventilation, which is very, very important. So these devices will make sure the air inside the home is clean for the health of the residents. Duct sealing. So all the heating pipes and so forth have to be sealed and insulated in order to conserve energy. What are some of the benefits of energy efficient buildings? Of course, as the word says, it's energy. So we are saving energy, thereby environmentally friendly. For the owner of the building, he saves money by being energy efficient, reducing electricity for lighting and energy efficient appliances will help him to reduce energy, lower maintenance cost. It will enhance the property value. But the most important thing is it's environmentally friendly. So when we turn off the lights that's not in use in a home, we are being energy efficient. Little things like that. Taking shorter showers, unplugging your computer, and so forth. And this is like now you would have heard of zero energy buildings. So this is the goal of many institutions now. So they're going with green roofs and solar panels, even wind, harvesting renewable energy sources, motion sensor bulbs, and just like reading a few of the benefits that are mentioned here. This is the energy efficient building, John Oliver Design Building at UMass. Sometimes I take the students for a field trip here. This is LEED certified. So LEED refers to Leadership in Energy and Environmental Design. It is a rating system for design, construction, operation, and maintenance of buildings. So it is like a rating system. So you'll come across LEED, like if it's LEED certified, the building is very sustainable and green. So when you say green building or sustainable building, see, the definition of sustainability is you take into consideration the 3 P's, right? Planet, people, and profit. So we are applying the principles of sustainability in a building. So in the structure and application process that is environmentally responsible, and there is also a profit to people. So this thinking goes from planning the building, the site construction, site details, design details, operation, construction, maintenance, renovation, and demolition of a building. So if it has to meet the 3 P's of sustainability, it has to efficiently use energy, water, and all the natural resources. It has to protect occupant health and improve employee benefits. It has to reduce waste, pollution, and any kind of environmental impact. So how to design an energy efficient building? There are 3 main steps. One is called bioclimatic architecture, where you will take into consideration the shape of the building, the orientation of the building, the solar properties in that region, and then make it as passive as possible. That is called bioclimatic architecture. That means you're taking into consideration the environment of the region to harvest its benefits passively without using energy. Like you would have heard of south-facing windows, right, in New England, that will harvest the most light and keep the homes warm in summer, in winter. The second concept is high-performing building envelope. So this is where the insulation comes into place. Glazing of windows, double pane windows, sealing of your attics, and avoiding thermal bridges. So this is where the most energy is lost. They are like junctions in like water pipes and so forth. And high performance ventilation, because ventilation is vital for human health. We have to get rid of the stale air and bring in fresh air. Heat recovery systems and so forth. I thought bioclimatic architecture is as old as man himself. Here are some very old buildings. Here in 200 years ago, this was taken into consideration. But like modern architecture, it's all about aesthetics, high ceilings and so forth, but it's not very energy efficient. So here vernacular, that means traditional architecture. So this is a building in Spain. You can see structures like this in other parts of the world too. And you can see how the pitch of the roof is. So it is very climate friendly, and it is trying to harvest heat from the natural features of the area. Here's cave dwellings in again in Spain, I think, and then it has a energy rating. So they have taken into consideration ventilation, insulation, and where it is facing. And this is Iceland. Turf houses, if you're a tourist, you can actually visit these old buildings. Again, you can see how the mountain itself is protecting, and then the turf, or sometimes it's even moss that is used to insulate the roofs. It is low ceiling to keep the heat in, and it is environmentally friendly. The building has been built with local materials. These are just some examples of bioclimatic architecture, but let me show you some more. Uh, so in what is bioclimatic architecture, we are taking into consideration the local climate and making the best use of solar energy and other environmental sources. So here you will take into consideration the height of the building. For example, in New England, right, if the ceiling is very, very tall, it is not energy efficient for a home. So the layout, even the colors, like if the building is dark, or sometimes even the buildings are intentionally painted in a dark paint in order to conserve heat. So all to make the best use of energy and passive energy. So passive would be like triple glazed windows. So when needed, it will reflect heat, and sometimes it traps the heat to keep it warm. Thermal insulation of the walls, making sure everything is airtight. Solar panels for renewable energy, and ventilation for recycling of the air. Here's more examples. Even water and plants are very important in hotter climates. And here you can see how they are using plants to cool the building. So if you go to Singapore and Malaysia, this is very common. You can see it's not only beautiful, but it's also trying to grow plants to reduce the carbon footprint of the building. Thermal accumulators, such as heat exchangers and pump, will capture the solar energy and use it at a time when it's needed, making sure the building is airtight. Moving on to insulating materials, because see, when you think about heat and how it moves in a building, there's conductive heat, convection heat, and also radiation, right? So insulating materials resistant to conductive heat is measured, and it is rated, and it is called as an R value. So the higher the R value of the insulating material, the better it is. Again, imagine the attic, right? So we have that cotton wool kind of a material in older homes. It can be fiberglass, cellulose, rock wool fibers, even foam boards. And then we have the spray insulation now, because it'll come from a pipe under high pressure, and then it can like reach all the nooks and crannies, making sure it's airtight and there's no heat escape during the winter months. So it is a very effective form of insulation, the spray insulation. So when insulation is considered, this would be the first step. So when an audit comes, this is what they're looking for. How efficient is the building in conserving the energy? So they will look for air tightness and also ventilation. Air quality is also important. So when you're considering insulation, you will talk about insulation of not only the wall and the roof, but also all the windows also. So energy efficient windows and doors are very important. High performance controlled ventilation. So where does the pollutants in the house come from? So here, if you go to the basement, there might be radon gas diffusing through the floor. And if you're storing a lot of paint and stuff like that, there can be paint fumes, chemical fumes. If the garage is closed, there can be carbon monoxide poisoning. We've heard these have been in the news. And cleaning products in the kitchen. If there is a smoker in the house, there's smoking from cigarettes. All of these, if you have animals like we do, there's like hair all over the place. Mold. If the bathroom is not cleaned routinely, they can be mold and bacteria growing. So all of this are very harmful for human health. So that is why a high performance ventilation system that will control the ingress and egress, that means the airflow inside and outside the flow. So fresh air must come, because we need to breathe in good oxygen, clean oxygen for our health, and remove the stale air. So a good ventilation system is very important. So the ventilation system goes hand in hand with the HVAC, the heating and cooling systems of the building. When people say energy audit, this is free. The government provides it, provides a lot of incentives also. So like in UMass, if you do an energy audit, if you're a homeowner, they will come and inspect your home. They will analyze the energy flow in the home with the goal of reducing your energy cost. So they even give like free LED bulbs when they do the energy audit. So here is some of the things they check is air can escape from your outlets and light switches, causing 5% of the heat loss in your home. It is wise to have programmable thermostats. Like if there's no one in the house, why waste energy during the day when you are at work? So there's you can set your thermostat. That is like a smart thing to do. Windows, they will ask you to insulate your attic and your windows where heat loss is common. And also by saving water by using smart nozzles in your shower head and so forth. And here's a picture of somebody weatherizing their attic. So they're they're insulating the house. And also, like, to make the house more renewable, it is advantageous to have solar panels. And you can see the solar panels in the south facing windows. And here's a very common sight when you are buying appliances. We always look for energy efficient appliances, because in the long run, it can save you money. Apart from saving energy, it is saving you money. So this is an initiative of the United States Environmental Protection Agency and the United States Department of Energy. So we have been taught to look for this blue label with the Energy Star when we are buying even a microwave or a stove. All appliances like fans and space heaters and any appliance that you might use. So that is the standard for appliances. Again, you are probably familiar with this. Many campaigns have happened for how we can reduce electricity by using the right bulb, right? So lighting accounts for 15% of the energy use. So the best thing is to turn it off when not in use. But LED lighting, light emitting diode, is the most efficient. So if you take the old fashioned incandescent bulbs, see, the lifetime is only 1,000 hours. And the cost is high. The carbon footprint is very high. Whereas if you compare it with the LED bulb, it is, see, 25,000 hours. And the cost is 30% less than in the incandescent bulb. And again, see, it's many-fold less, 4 to 5% less. It's using less electricity and its environmental impact is less also. So the wise choice would we should either use a compact fluorescent bulb, CFL bulb, or a LED bulb, because they are cost effective. They used to be expensive when they first came in the market, but now with several government incentives, it is cheap now. What is a energy efficient building? So this is the transition into the future. So it's similar to like an intelligent building. We call it as a smart building. So the smart building is using communication technologies like Internet of Things or sensors, software, online connectivity to monitor the different aspects of the building. And then it will collect data, analyze it, and it will generate smart decisions in order to reduce energy use in a building and make it more efficient. For example, some of the intelligent building criteria are to use renewable resources, passive design. So this is the bioclimatic, intelligent skins. So this is the insulation. And in addition, you're using sensors to monitor the heat and the ventilation and the cooling of the house constantly. And then it'll turn on and off as needed. So here is more expanded points about how a smart building operates. But I know like in our campus, like we've seen how doors open and close as needed. It's not kept open all the time. And the lights will turn on only when there's an occupant and when there's a movement. Another fascinating and most important aspect is to use renewable energy sources. So in this case of this building, there's a lot of solar energy. So the energy that is required by the building is made in the building itself. So the building will take energy from the grid only if there is not sufficient solar energy made. And if there's more than needed, it will throw it back in the grid. So this is the grid interactive efficient buildings. So this is the building of the future, where it uses energy only as required, and it is smart. So it will turn off appliances and devices when not in use with the use of sensors. So there's a lot to learn. So in the transition to energy efficiency, buildings are very important because it's taking 40% of the energy use in the world. And I hope that was helpful.